Right, it's 1:30 Eastern Time. We will get started for our AI-Ready Data session. Welcome everyone to the AI-Ready Data session at the 2025 East January meeting. And it's great to see many of you online, and we hope to have a really robust discussion today. As a welcome, I want to remind everyone that ESIP has a community participation guidelines, and please make sure you follow the community participation guideline. If you experiencing any unwelcome behaviors that's outlined in the community participation guideline, please make sure you can report to the ESIP staff, and that can be handled appropriately. And today we have a 90-minute session with 3 invited presentations and follow-up open discussions. And I invite everyone to go to the session notes in the Kiko chat for this session to sign in. And in this check-in, we have specific questions asking what's your main role related to this session, whether you are on the AI development side or data management side for today's discussion as background information we want to keep track of. And additionally, we already provided some resources, a link to the resources that's publicly available in the note document that's also available on the Sketch session page as well, including the checklist and also the summary of the World Data Systems AI Data Workshop review and the recordings, and also the public release of a very early version of the Brightband's AI-ready Ninja datasets that will be described by Daniel later on in the session. The idea of this session is really to further the discussion about how, as the community of Earth open Earth science data, moving towards supporting the AI research and development and application development. And about 2 years ago, we started the AI-ready data checklist that has been used by different groups. And also we received some feedbacks, including it may be use case dependent in some of the questions. So in this session, we want to drill into more details of different types of data and different types of use case and how that might be further used to improve our discussion on AI-ready data for the Earth environmental data overall. And without further ado, I want to kick off the session with our first presentation by Emily and Andrea from the World Data System International Technology Office. Let me start sharing the screen for you all. While I'm doing that, Emily and Andrea, please unmute yourself, introduce yourself to the speaker, yeah, I need to reshare because we have a recording from Chandra. So please go ahead.
Okay, so hi everyone. I'm Andrea Budak, a data science developer with the World Data System International Technology Office.
And I'm Emily Altman, and I'm also a data science developer with the World Data System International Technology Office. And we're very happy to be here to give a short presentation today.
First, I'll give you a quick overview of the World Data System International Technology Office and our motivation for this project. Next slide, Doug. As this office is hosted at the University of Victoria, we acknowledge and respect the Lekwungen peoples on whose territory the university stands, and the Lekwungen and Sandwich peoples whose historical relationships with the land continue to this day. Specifically, as people who are working in the data repository community, we recognize the importance of improving our practices with data by incorporating the CARE principles for Indigenous data governance. Next slide. Yeah, there we go. And as people in the data repository community, our mission is to enhance the capabilities, impact, and sustainability of our member data repositories and data services. The World Data System was created to support data sharing across national boundaries and to cohesively work with the data repository community across disciplines. Next slide. Here you can just sort of quickly get an overview of where our members are located. We had some new members this fall, so this is a recently updated map. We are trying to gain more geographic diversity in our membership, so we have some work to do. Our regular members are represented by the orange color on this map. We also have our offices, staff, and scientific committee on here. Next slide. And then this is more goes into a bit more detail on scientific committee, who governs what we do. Recently, there was quite a bit of work for our action plan, which will be launched next month. And as you can see, we are aiming for diversity both in geography and in the discipline that everyone specializes in. Along with our members, they guide us over time and influence our direction. Next slide, please. The World Data System has two offices. The International Program Office is in Tennessee, and we're from the International Technology Office again, which focuses on the technical challenges to data sharing and data repositories. And this is how our mission and the focus of our office combined and got us working with AI data readiness. Next slide. So quick overview of our workshop that happened back in October. We ran it was for data repository representatives who are involved with curating metadata and data, although anyone who is welcome, and many interested parties joined us. Since data repositories have an essential role to play in providing quality data to support quality outputs for AI, the emphasis was on assisting repositories in their pursuits to deliver AI-ready data by examining and discussing the AI data readiness checklist. Nearly 50 people joined us from across the world, and we did get people from a wide range of places and disciplines. The majority of the workshop was dedicated to an in-depth review and discussion of each of the checklist categories. And now Emily will take us through the feedback that was discussed at the workshop and give a brief overview of our pilot project, which is still ongoing.
Great, thank you so much, Andrea. Next slide, please. This just has a brief overview of the different sections of the AI data readiness checklist, and I'm not really going to go into them right now because I believe most of you are probably familiar with them, and we're short on time, but this is just an overview that has the 4 sections: quality, documentation, access, and preparation, and lists the questions that are in like a brief overview of the topics of the questions that are in these categories. Next slide. So I'm going to just present a short overview of the feedback that we received during the discussion at our workshop. Some general feedback. The participants wanted a more comprehensive glossary for the checklist. Many of the terms such as raw data, processed data, derived data, synthetic data, single source, and cloud access are vague or could have multiple different definitions. And so having a clear definition for each one in the glossary would be very helpful. Also, the participants wanted justification or reasoning, just something brief, but to just have that for each question so that they would understand where this was coming from and how it relates to AI. Under the documentation section, participants thought there should be consideration for the care principles added. This is very important for any data that is relating to Indigenous peoples or being taken, data collected on their lands. And also, they thought it would be valuable to add a question regarding whether this data set had already been used for AI previously. Under the access section, we thought that this section provides a good opportunity for the data provider or curator to set expectations for AI models to cite the data that they use and train on. Also, restricted data access via authorization can be challenging in the case of AI or machine learning, as it may be difficult to verify legitimized machine access And on the other side of this issue, there's a concern that AI might be able to get access to data that it shouldn't have access to. We also felt the need to consider large data infrastructures and the fact that machine learning training data is often very large. So it's important to think about whether users can download data. And if they can't, are there data visitation services provided by the repositories for users to access and manipulate the data remotely without needing that space? And next slide, please. For preparation, people were generally happy with these questions, and they thought that most of them seemed appropriate across disciplines. But adding a question such as how complete is the demographic coverage could help to disclose bias in other disciplinary areas besides earth sciences. Okay, so for quality, this is probably the most challenging of the sections, and most of these are more like considerations and discussion points. So first, data versioning practices vary widely, and so we need to have more consensus on best practices in order to have more clear machine actionable usage of data versioning information. Similarly, curation practices also vary widely, and we don't have a very good metric for them. There are certifications such as Core Trust Seal, but they focus more on technical quality rather than data quality requirements. And so therefore we need to widen the scope of curation expectations to include data quality, but this does require a lot of work and resources. And finally, many metadata standards, for example, Dublin Core, have free text metadata for questions related to quality and bias. Most standards lack controlled vocabularies for these issues, which is a setback for machine interoperability. And developing controlled vocabularies might not work for every situation, but it would still be very beneficial. Next slide. So as a follow-up for our workshop, we recruited a group of participants to implement the AI data readiness checklist using a data set of their choice. Our cohort includes 14 participants from 12 organizations, many of whom attended the workshop. We're hoping to receive valuable feedback from the pilot cohort's implementation experiences, which can hopefully improve the data readiness checklist. And we also hope that the feedback from the pilot will serve as input to future steps, such as automation or partnership with AI researchers or developers. And below, I just have a brief timeline for our pilot. Right now, we're in the January one-on-one session, so we're meeting individually with participants to discuss how their progress on the checklist is going and any difficulties that they've had. And next month, we're going to have our concluding meeting where participants will share their experiences and feedback with the checklist. Next slide. This slide just shows the varied organizations that we have participating in our pilot. Next slide. And I just wanted to briefly mention the International Data Week, which is coming up this October in Brisbane, Australia. The World Data System is a co-organizer for this and is going to be great. So just wanted to mention that really quick. Next slide. This just describes our the two offices, the International Program Office and our office, as well as we want to thank our partners and funders. Next slide. Thank you. And I believe we'll probably have a question period later. But for now, we'd like to share a video from one of our pilot participants, Chandra, on her experience working on implementing the checklist.
Informatician with NSF's National Ecological Observatory Network, or the NEON project for short. I am one of the participants of the WDS AI Data Readiness pilot, where we were asked to evaluate our data using the checklist provided. And today I'm going to chat very briefly about our experience sort of going through that assessment and what we got out of the exercise. First, however, of course, I want to give an intro to our project and an overview of our data set and get a bit into about why I was interested in participating in this pilot in the first place. So NEON is a unique long-term ecological monitoring observatory distributed across the United States, which includes Alaska, Hawaii, and Puerto Rico. We are a research platform for discovering and understanding specifically the impacts of ecological changes like climate change, land use change, or invasive species. And we do this by gathering long-term data on ecological responses to changes in land use and climate, and on feedback with the geosphere, the hydrosphere, and the atmosphere. We have 81 field sites situated across 20 broad ecoclimatic domains, which are distributed into 47 terrestrial sites and 34 aquatic sites. We also provide a highly coordinated system of open data for monitoring over 180 critical ecological and environmental properties, or data products. So, for example, these are data such as surface water level, water quality, air, groundwater, soil temperature, barometric pressure, that kind of stuff. And so the intent is to collect these data across these domains for 30 years, with the observatory becoming fully operational in 2019. So we've been in full swing for about 6 years now. NEON collects data and samples using an extensive network of automated instruments and field technicians, as well as through airborne remote sensing. Where logistically possible, NEON co-locates those terrestrial sites and the aquatic sites within the same watershed to try and capture connections within that ecosystem. At all field sites, data are collected via standardized protocols to allow for proper data assessment across time and space. So we've essentially got 3 categories of data. First, we've got our automated instrument systems. So this includes the meteorological and eddy flux data from the instrument towers, phenocam, soil sensors, anything that could be considered continuous and automatic. Second, we've got the observational sampling, which encompasses all of the observations and physical samples typically collected by people in the field. So these include data from small mammal trappings, ticks, mosquitoes, etc. And third, we've got the airborne observation platforms, which use light to aircraft carrying instrument payloads to gather photos, LiDAR, and hyperspectral data via remote sensing. So I help manage and make available the data and samples collected by the observational sampling team, which are stored physically at the NEON biorepository at Arizona State University. So these are typically going to be raw collected samples like beetles, mosquitoes, plants, but also include downstream post-analysis samples like DNA extracts or microalgae filters, and can also include non-biological samples like rainwater or soil plugs. So I was interested in being a part of this pilot for a couple of reasons, but primarily I wanted to see how we could expand our data in a way that focuses on AI, but also because I really haven't seen much conversation about biodiversity data and AI from the repository perspective. So although geosciences have been engaging in AI readiness conversations, obviously the biodiversity community has not super participated broadly. Many of the conversations that I've seen, at least so far, have focused on applications of AI to biodiversity research versus sort of building processes to support AI. For instance, wildlife monitoring is benefiting from AI. We've also got automated species identification from images that are helping to streamline taxonomic works. And so these examples sort of highlight that potential for AI, but they remain relatively isolated efforts rather than something comprehensive or community-wide. So some key points to be aware of biodiversity data is that first, it has primarily in the past sort of relied on physically collected samples, resulting in much smaller data sets. However, methods for collecting this information is of course growing rapidly, and although our data set sizes are not quite as large as some geoscience data sets, we do need to start having these conversations. And second, most biodiversity data is in the form of primary biodiversity data, which describes what, where, and when something was recorded. However, with modern techniques, these records would be expanded to include deeper and more contextual data, such as genetic data or image or acoustic data. Looking forward, one of the key questions is how biodiversity repositories can adapt to meet these demands. Currently, I would argue much of this data is used for statistical modeling for a specific research question, but as data sets grow and ways of recording organisms expand, so currently we're expanding through methods such as community science, remote sensing, eDNA, repositories need to become more interoperable, scalable, and capable. Preparing for AI readiness now will ensure that biodiversity data remains valuable for answering future scientific and societal questions. Working through this assessment, we really wanted to not only analyze our own data set, but also keep in mind the broader biological community and how the topics discussed applied or didn't apply at large. So generally, we had two major takeaways. First, the checklist was really helpful in revealing sort of weaknesses in our current practices. Along with an alignment to AI, this checklist helped us align with FAIR principles, so making our data set more findable, accessible, interoperable, reusable. And so this is a long-standing principle of data management within the biodiversity community and is definitely a side effect we were happy with. The questions also allowed us to critically evaluate how our data is being presented to the public and what may or may not be clear to users. So for example, many of our answers to seemingly simple yes or no questions were, well, it depends. It depends on the context, which could be attributed to a lack of clear distinction when publishing our data, but also could be attributed to complexities of the data itself. As either way, not being able to answer all of these questions sort of easily revealed how some topics might be confusing for users. The assessment also revealed several weaknesses in how our data is currently managed and presented. So for instance, we heavily rely on external systems like GBIF, which is a biodiversity aggregator, for our versioning, which creates gaps in our own internal version control. Similarly, the assessment highlighted that many of our assumptions about the data sets are undocumented. So for example, it might be generally understood that there are biases in the people identifying the species, right? We are a very big project. We've got multiple people sort of doing those identifications, and there's a bias there. But that's not something that's explicitly described anywhere. It's just kind of assumed that you know that. Additionally, our metadata could benefit from some improvements. By including more dynamic details for filtered data downloads, such as spatial, temporal, or taxonomic coverage, we could make data sets more transparent and usable for AI. Another key takeaway that emerged was sort of the complexity of biodiversity data sets in general and how it may make it difficult to have responses to some of the topics that the checklist described. So as I mentioned here, a lot of the questions in the assessment process required sort of these context-dependent answers, right? It was assumed that it would be a yes or no, but I feel like most of the answers were, well, it depends on the context. And I'm not sure if this is due to the fact we were trying to use maybe a unique data set in this assessment, or if that actually might just be the case for all data sets in some way. But either way, the NEON project is extremely unique in that it's designed to be a relatively standardized project across space and time. So other project-generated data sets usually revolve around a research project and may have documented biases, completeness, etc. However, as stated earlier, that currently the data sets that are more aligned to AI analyses, so these really, really big data sets, are typically not these kind of projects. They don't have standardized protocols. They're sort of these ad hoc collections of data and samples. So, answers to questions like consistency, the answer to those will inevitably be no, like these data are not consistent. Versioning, for example, is not something that has really sort of made it into the biodiversity community, given that most of these collections are treated as live and are subject to daily changes, although there are examples of versioning in sort of smaller data sets or versioning via data download GOIs for some of those larger data sets. Overall, I really sort of enjoyed the assessment and sort of thinking about our data in these ways, and I really encourage you to sort of to do it yourself. It ultimately doesn't take an incredibly long time, and I think the most difficult part, for at least for us, was trying to figure out if a question applied to our data set or not, or how to answer it. There are definitely improvements that we can make, which was one of my primary reasons for going through this checklist. And I think I can also, and starting to think about how these assessments can be applied to biodiversity data at large and sort of begin to start these conversations is really important. If you've got any questions, of course, feel free to email me or check out the NEON website. We're always looking for feedback and users, and many thanks to Kelsey Ewell, who went through this checklist with me, and of course, thank you to the organizers for setting this up and inviting us to the pilot. Yeah, thanks.
All right. Thanks, Andrea, Emily, and also Chandra for sharing that. And also thanks to those who have been in the session asking questions. And if anyone has any questions, either you can type in the chat or raise your hand. For some time for maybe 1 or 2 questions for Emily and Andrea before we move on to our next presentation. But at the end, we still have some time for open discussion for this session. And also, I forgot to mention, we invite everyone to take notes collectively in the note document if you are willing to. I don't see a hand or question in the chat. If not, we can come back, and it's very helpful to hear on the data repository and data system point of view here. And our next 2 presentation will be diving into more details in some of the numerical weather prediction, as well as the some other types of data, observational data for in earth science. Stephen, please go ahead. Stephen Haddad from Meta.
Super. Thank you, Douglas. Let me just show. Okay, hopefully you can see my slides okay.
Yes.
Super. Okay, hello everyone. I'm Stephen Haddad. I'm from the UK Met Office. As Douglas said, I'm in the data science research and development team there. So I'm giving our perspective on the work in my team, which is primarily responsible for how we can sort of embed and accelerate good data science, machine learning, AI practices within the Met Office research. And so that's the perspective we're coming from, putting together some material to make data readiness a sort of standard thing as part of research in the Met Office to accelerate adoption of AI and ML. So I guess a good starting point is what's the context, the sort of state of data readiness at the Met Office. So like a lot of our organizations, we have a long history of data curation for a variety of uses, the varieties of sorts, model data, observation data of many sorts. And what's really new about this is that AI/ML is a new use case for these data sets. So it's trying to understand what's different about that, and that's kind of what the journey we're all on in this group. And so there's a growing awareness, though, within the Met Office of this use case and a desire to understand how to accommodate that, but not necessarily the people who are responsible for the data sets, not necessarily being people familiar with doing machine learning practitioners themselves, so looking for guidance on how they can make their data sets more available and usable for this. And so they're looking for guidance to embed good practices. So this is something I took to think about how my team could take this forward and help people get to grips with what data readiness is all about. And so thinking about it from a few different perspectives. So I guess our team is primarily thinking about on the point of data users, so somebody wanting to be able to easily find and use data sets for creating machine learning models for a variety of contexts, ideally bringing different data sets together. So that's our perspective, but then we want to kind of connect with the data curators across the Met Office who need some sort of benchmark to guide them, whether they're sort of doing the right thing. And also think about informing infrastructure requirements. So we've just starting to get access now to our new compute infrastructure, including a new supercomputer and all that sort of thing. And so there's requirements that are informed by the way we're going to be using data for AI ML. And so kind of understanding what's good, good data set kind of informs what's a useful infrastructure to support those data sets as well. So thinking about all those use cases in how we take this forward. So what sort of ideas have you come up with in terms of how to embed data readiness across the Met Office? So one is just awareness. So that will come about through various activities, but particularly thinking about training. So some sort of training activity to help people get started with the checklist and the concepts of data readiness and what tools could support that, and whether how to then help them make use of the sort of best practices that are implied in the checklist. So that's the sort of context for the activity that we wanted to plan. So we're also thinking about what the challenges we'd found so far and kind of telling people about the checklist as we started kind of promoting it around the Met Office, challenges that we'd encountered. So sometimes the questions can be kind of, if you're not familiar with what the concepts, they can be kind of vague or hard to interpret. So someone mentioned some of the glossary in the previous talk, those sorts of things, and so that's continued to evolve and it's gotten easier, but that's something people initially struggle with. So how could we help them further through this material? One of the things people have struggled with in talking to them about this was having concrete examples to see, okay, what does this mean for a particular data set in a particular context? And then some concerns around whether questions were applicable or not, and what you do with that, or whether there's things that people care about that aren't in the checklist. And some of them is just a case of, well, if the data is not right there with the data set, it can be not always straightforward to find the information you need to do the assessment. So how could we address some of these concerns and other concerns that people had through some sort of tutorial training activity to help people get started? And so over the last sort of 6 to 12 months, people in my team have been trying to create some tutorials in the form of Jupyter notebooks and others to kind of walk people through the process of doing an assessment, what it would look like, and create some concrete examples on real data sets, and also have a companion machine learning model, sort of a toy model created with that data to demonstrate, that how it actually works in terms of using it for ML and AI, and it would also help people. Having an example helps people answer some of the questions around some of the categories on the checklist. And the idea is that hopefully these tutorials form a sort of template so that people can use for future, whether for their own data sets or data sets that they want to make use of, creating new data sets. And so kind of hopefully helps streamline a bit the process of embedding kind of data readiness, awareness and assessment in standard practice for research at the Met Office. And we've also started then exploring which of these things could be reasonably automated or semi-automated, at least helping people kind of find the information that they might need for the checklist. Or, the faster that the process can be and the more streamlined, the more likely we are to get people to engage and adopt it. So thinking about that. Why is my slide not going? So within that, we've selected then a variety of data sets so that hopefully people can find something that looks a bit like their data set to start with as a tutorial, and then use that as some sort of template for doing something with the data set in particular they're interested in. So try to have a variety of sources. So for example, some Met Office data sets, some NOAA data sets, we've got the ECMWF data set, and also different types. So having kind of gridded model data type data sets, tabular data sets, and whether it's image type data sets, and see. So you can see how the assessment process might be different for those different sorts of things. And also because hopefully then we can provide guidance on what a question might mean for a particular sort of data to, again, help make it more concrete where some of the concepts are more abstract because they need to be applicable to all the different sorts of data. And also try and get model data sets, observations data sets, as many as we can find within limits. And certainly we hope to grow that to have more examples and pull in some existing examples from elsewhere around as well as a connection. So we're building on the work elsewhere in the community as well. So far we've got some tutorial material which we're currently testing. The advantages and disadvantages we found so far. So we've started kind of showing it to some people in my team. And the feedback's been that it's useful to be able to walk through an example and see it in a more concrete way. And although people haven't really started using it yet, the benefit of having a sort of template helps guide you through and demonstrate what it is. As we be putting the material together, I guess one of the disadvantages of building on this way is that you are then interpreting some of the questions and sort of narrowing it down, and our interpretation of what a question being might be different from someone else's. So we still want to point people back to the checklist as the ultimate source of that information to guide them. And of course, there's always going to be different sorts of data types because there's a great diversity of different data for different applications. So as someone said in the previous talk, the ultimate always there's an it depends element to guiding you through this. So you're not going to be able to cover all data types, but I think one shouldn't get in the way. Try and have some examples of common data types and people can build from there. So obviously the particular tools we've chosen, these are all done in Python and Jupyter Notebooks because those are common tools that we use in our team. But of course, there are other people around the Met Office for whom those are less familiar. Maybe don't know Python. Lots of people use R, but data readiness might still be relevant to them. So there is some downside that it's still kind of narrow in terms of this example, but hopefully useful enough. So now we've got this tutorial material. We're currently in the process of starting to publicize this and work with some partners. So we're organizing a hackathon around data readiness with Met Office staff and some partners at NOAA to actually put this material into practice and see how well it works, actually assessing some data sets. So we've got over 4 sessions. We're going to have a sort of data triage session where we select some data sets on different themes and see how easily we can do the assessment. What are the stumbling blocks? What would this be like? And the idea with having this is that a lot of these questions, you do need to kind of have a particular problem in mind to be able to more easily answer them. So the idea is having a hackathon where we're looking at particular theme, a sort of an imaginary goal, really, around we want to select data sets for a particular purpose, helps people make choices in answering the checklist questions. And then the idea is to reflect on how that goes and see whether we can make some improvements either to particular data sets people are involved with or to the assessment process itself, either tutorial or maybe create some more automated tools, depending on how the initial sessions go. And the aim is primarily to then continue to promote the awareness of data readiness for particular within the Met Office and partners, and hopefully this is something we can continue to collaborate as we're both organizations are looking to accelerate the use of AI ML and doing similar things. If we can work together to on this, hopefully we can also share data more easily between our organizations and then have more data that we can exploit for this purpose. So where are we going with this next? So the idea is we're going to do some assessment of data sets and we'll share that and publicize them, hopefully with CSIP group and around our organizations. And the idea is this is a pilot that we want to run with several different groups of partners that we have within the UK, partners we have for developing our existing physics-based NWP models. So to embed that across partners to be able to, again, facilitate data sharing with those partners to accelerate AI ML adoption across those partners. and then hopefully embed it in particular projects we're working on in our team to understand the data sets and hopefully accelerate that initial part of the project that we're aiming to, and enable us to make better use of partner data sets and enable partners to make better use of our own meta-office data to exploit our rich source of data. And that's my experience. Happy to take any questions.
Stephen, I think we have a general comment or question from Matt from Data One, is asking if there's anyone willing to share the assessment outcomes. And I believe one of the tutorials that, or in some of the notebooks, in the tutorials that MetaOffice put together included some of the checklist assessments for some of the data sets, right, Stephen?
Yes, that's right.
Yeah, and when do you know if that GitHub is going to be made available for general public?
Yeah, so the idea is we're running the hackathon, as you know, now, and the idea is that will be our kind of beta testing, and once we've done that, then we'll be in a better position for hopefully the tutorial to be comprehensible, and then plan is to open source it after that.
Thanks, Stephen.
So hopefully sort of towards the end of February, and then try and share that through ESIP channels as well, so people can see that.
Great. Thanks, Stephen. And Andrew and Emily, I'm just circling back to you to see if you want to share if any of the pilot projects are willing to share. From the cluster side, we have done a few of the assessment activity in the past, and some of the people are willing to share the assessments. So we're compiling a list of those assessments outcomes and that we can share. So I'm going to see if anyone from the pilot are willing to share. I see both of you are muted, so.
Oh, yeah. We'll ask them at the final meeting and potentially in follow-up emails whether they are willing to share, and then report back to you. So that will be towards the end of February.
Thanks. Matt, please go ahead.
Yeah, besides the pilot, I'm curious that this checklist has been around for a couple of years now. Have there been other groups that have implemented it and made documents public just as part of their normal operations, like in NOAA or NASA or other groups, or are these all internal right now to implementation teams trying to figure out how to use it?
I don't think it has been operationalized. So I do know that NIH also used this checklist for the assessment for their specific data repositories on the I forgot which data set they had. We had a workshop, and they also published their assessments and lessons learned. I can try to find that link and share that in the notes as well. And the idea is that we are hoping that we can operationalize that. One of the steps towards operationalizing it is some automation should happen to make it easy to use it. Because right now, I think some feedback is that people have been using a lot of manual assessments in that way. And with the automation project we're trying to kick off at this moment, and that we're trying to use the metadata have been collected or included in the data set itself directly to make the assessment easy towards operationalization. Any other questions?
Doug, I'll just follow up on that and say that the reason I ask is because we're doing the same thing. As you know, we've talked in the past about us working on the MetaDig system, the metadata improvement and guidance system that we run at Data One. And that, tries to automate the assessment process across a, large number of 60 different repositories. And so we're trying to get a sense of how we could adapt that system to use the AI readiness checklist and try to create new, very atomic checks. And it would be very helpful to be able to see examples of how people responded to those. Like when I looked at them, I ran into the same challenges that I think other people have cited about sort of the vagueness of trying to understand how to answer the question specifically. Oftentimes I felt like a lot of the responses to the questions would be narrative as opposed to a yes or a no or a structured response. And for the automation side, I think structured responses would be much more tractable and potentially useful. So I was trying to figure out where people might have been able to find areas that could be more structured like that and automatable rather than the narrative types of responses.
Right. I think with Stephen's example, I think they're trying to make it into a more Steve, I'm gonna let you because you showed a little bit earlier this morning about the you're using a notebook for that.
Yes, so hopefully the idea is we're trying to make some of the questions a little bit by for particular data like data set types, we can kind of narrow down some of the questions and have, for each of them have an example of a real data set in the repository or multiple to share. So hopefully that will often when you see a worked example, it's easier to see how it applies to your own situation. So hoping that will assist with that.
Thanks. We can come back to the topic for another round of discussion before. And so we have one more.
Excuse me, Doc, can you hear me?
Yes, Pen, go ahead.
Okay, I'm having trouble showing my hands. Can I ask Steve a quick question?
Yeah, sure.
Go ahead.
Okay, thank you. Steve, thanks. The template you putting together, are they primarily for the Met Office data sets, or because you have showing some of the examples, the data set you selected?
Yeah, certainly the idea is that it's not Met Office specific. We're hoping it will, be I guess data sets mainly of interest to the Met Office, but in our examples we've used a selection of Met Office, NOAA, and ECMWF data sets so far. And we're hoping to continue to expand that selection. So the idea is hopefully it's useful to anyone in the AI data readiness community around Earth Sciences ESIP.
Great.
Hopefully we can share that and potentially continue to grow that list of examples. That will be so people can make it easier for people to adopt.
Thanks, appreciate it. I'm looking forward to see template.
Thank you.
Thank you. Without further ado, I'm gonna let Daniel Rosenberg from Brightband to share a specific project they have been working on the observation data for numeric weather prediction application.
Awesome. Thanks, Douglas. Just confirming you all can hear me and see my slides.
Yes, great.
Awesome. Well, thanks again for inviting me to chat with everyone today. I followed this community for a long time, and it's really a pleasure to engage with everyone here. Like Douglas mentioned, I'm presenting some work that my team has been doing in developing a new data set for where we think there's going to be a significant research push in artificial intelligence for weather forecasting applications in the very near future. And I'll sort of foreshadow a little bit by saying that we were as cognizant as we could be of the ESIP, the data readiness cluster, the AI ready data checklist when we were thinking through how to develop this data set in partnership with our colleagues in NOAA who are collaborating with us on this. And so it's great to get a chance to explain everything that we're doing. I just want to briefly mention who we are, because many of you might not be, some of you might know my name from the Pangeo community and other adjacent epistemic groups, but you might not be familiar with Brightband. Brightband is a new initiative that I co-founded this past summer. We are a public benefit corporation that has a chartered mission statement of making AI weather forecasting tools available to all to help humanity adapt to increasingly extreme weather. In a nutshell, we believe that these new tools and the opportunities that they arise and in applying artificial intelligence to weather and climate are going to be very powerful, and they're going to allow scientists, developers, engineers, and many organizations to come up with novel solutions to quite important problems. But there's a risk that these tools, the ability to develop and run them, gets concentrated in the hands of a relatively small group of people, owing to the complexity of not only building and deploying the models, but feeding them data to actually train on and then run at inference. And so we think that this is an antithetical outcome to the ethos of the weather and climate communities. And we think that that would be an outcome that really doesn't enable society to adaptively use these tools to solve many interesting problems. So, we as an organization are trying to bridge this gap. Like I mentioned, we're a public benefit, so we're not purely a nonprofit. We are looking and thinking of ways that we can, sustain this in the long term through commercialization and productization. But at least everything that I'm going to discuss in the next couple of minutes is things that we've made a commitment to making free and open source, no strings attached whatsoever. So to frame the technical problem that we're talking about, for those of you all who have followed the AI for weather forecasting world, you probably know that there's been this Cambrian explosion of technology over the past 3 years with, and nowadays you can download pre-trained model weights for a model from Google. It doesn't quite fit on your consumer grade GPU that you'd have, in a gaming computer, but you can rent an instance on S3 or Google Cloud for about $2 an hour. That can crank out a forecast of comparable quality to the NOAA GFS or the ECMWF IFS in about 2 to 3 minutes. So it costs basically a quarter, certainly less than a cup of coffee. And this has been wildly successful. And there's a new frontier emerging where rather than use an era of models that are kind of emulators of numerical weather prediction or general circulation models, we're going to be applying them in a much more foundational context, effectively initializing them directly from data, kind of doing a simulation as we go. And people scoffed at this idea as science fiction about a year ago, but in the intervening year, we've actually seen 2 very high-profile works that demonstrate that there's very much a story here. 2 that I would call your attention to frame the problem here are Anna Vaughn's fantastic aardvark weather paper from earlier this year, and a very recent work by the ECMWF team called Graph DOP, or I'm blanking on what I think is direct observation processing is what the DOP stands for. The key thing with these data sets is that in a single year, we've gone from working with highly reprocessed level 2 and kind of level 1 adjacent data that's all coerced into something that researchers can play with, to the ECMWF team basically dumping out the raw data from their level 1 feeds that they'd feed into their assimilation processes in their models. And this is a completely new territory for the AI and ML practitioner community who are not meteorologists typically, who don't really know a lot of the challenges and provenance of meteorological observations and data that we have to work with. And it creates this massive barrier for them to be able to continue to advance the technology. And we think that we can help solve this by adopting fair and open data principles and opening up data sets to the world for researchers to play with. So what are some of these challenges that we face with observation-driven weather forecasting very specifically? The key thing is that these data are large, multimodal, and heterogeneous. There's many different types of sensing systems in the world, everything from surface stations to buoys to weather balloons and gliders. There's plenty of gridded and raster-like data. Although what's interesting is not all raster-like data is a lot. What you get from a geostationary satellite is very different in character from what you get from a polar orbiting satellite or a satellite in low Earth orbit. To go along and make the problem more difficult, if you query 3 different providers of weather data, you'll probably come up with 10 to 20 different ways that they distribute and disseminate some of this data. It's many of the problems that this community is very well familiar with. There's a multiplicity of distribution technologies, everything from throwing data behind APIs, uploading FTPs or other publicly accessible distribution services. Data is published in every format under the sun, ranging from proprietary, kind of what I would call old school or legacy binary formats like buffer and grib to more contemporary HDF5. There's plenty of ASCII and bespoke products out there as well. It is kind of the Wild West. Even more challenging is that many data are distributed with conflicting metadata standards and documentation. Classic example of this is when you decode GRIB forecast data from NOAA versus ECMWF, you very traditionally run into conflicts in the naming of variables and sometimes even units, which causes a lot of confusion downstream for users. An even more important issue is that there's a multitude of different licenses from which the data is distributed, which makes it challenging for end users who want to build, value-add products on top of them. So all of these challenges really impede research progress, and then we're trying to break down some of those impediments as much as we can. So to do this, we highlighted a data set that was actually recommended to us by our collaborators at NOAA PSL. Some of you might be familiar with this NOAA-NASA Joint Archive. We're going to call it NINJA for short. NINJA is a curated data set funded by a collaboration between NOAA and NASA to basically collect all the, a very large archive of historical data that can be used to assimilate into numerical weather prediction models for purposes of reforecasting, which is taking your current configuration of your forecast model and doing hypothetical forecasts forked from history, as well as reanalysis. So the project of kind of making a continuous weather record with a consistent modeling framework or system. And the Ninja dataset by itself adheres to many of the standards that are on the AI-ready data checklist. I'm not going to go piece by piece through them, but I want to call out a couple things. For starters, it's published in a single and consistent archive structure and in a single file format at that, which is quite nice when you have all these heterogeneous multimodal data sets. Having a single way, a single file representation of it is quite advantageous from a software developer or AI practitioner's standpoint. Unfortunately, it's a legacy format called Buffer, which we'll talk about it again in a second, because it's kind of the least ready you could make data for AI applications, unfortunately. The data set has great documentation, and the NOAA team has been constantly updating things like graphics like at the right, which show the inventory of the data, and they have it broken down by all different we'll call them metadata slices. The data is fully self-documenting to the extent that Buffer allows that. And it's consistent, but owing to the fact that it's all coming from a single provenance and they're using a single format to disseminate it. The data is also published openly on AWS S3 under a highly permissive license. So anybody can come in, download, replicate, build on top of it, no strings attached. It's kind of the best things possible from a empowering user adoption and uptake perspective. And the data is also prepared and pre-processed in a very consistent fashion. The one caveat is that is hyper-focused on these reanalysis and reforecasting applications that I mentioned, which means that it's designed to feed into NWP data assimilation, and that's it. No other use cases were imagined from the first go of this data set, which again is a solvable problem, but it was a limitation from when we got in there. So I won't dwell on this, but for another community that I presented this presentation at, we just wanted to establish that this is also an authoritative record of the data. This is not like a small sampling. And just to demonstrate that, I pulled a quick snapshot. On the left hand is NOAA's their climate data record from the NOAA 18 AMSUA instrument. And on the right is the equivalent data as available in Ninja, barring some minor changes in data volume, which are really owing to the quality control that's done on the NOAA side for the Ninja archive. These data sets are effectively identical. I don't have it on this slide, but if you were to plot a histogram of the brightness temperatures displayed here, they're statistically identical, again, minus those small issues in volume data. So I mentioned this problem with Buffer, and I want to spend a second deep diving it a little bit because it's a cautionary tale for developers who want to create AI-ready data. If you're not familiar with Buffer, there's a Wikipedia link there, but Buffer is a legacy format widely used in what I would call the internal sausage making of the numerical weather prediction system, particularly data simulations. How do you feed all the data into the weather models to initialize them? Buffer has a lot of things going for it. It is a binary format, so you get very small file sizes. It uses a schema-based encoding for heterogeneous data that has offline data dictionaries, so it's very easy to decode and understand what's in the data. It's record-based, which is fantastic from a dissemination standpoint once you've kind of read it out of its binary format. And it's fully geospatial and temporal. So you can take, say, a geostationary satellite raster and trivially represent it in this format. You can go back and forth quite easily, actually. The biggest challenge, though, is that there's an extraordinarily fractured and limited software ecosystem and tooling for working with these data. And most importantly, if you're on either side of the Atlantic Ocean, you're probably looking at Buffer data that has software is incompatible with other organization software. So for instance, ECMWF software struggles when reading or decoding data that NOAA has published in Buffer format and vice versa. And these are always engineering-based solvable problems. But again, these create barriers of friction, which are inconsistent with this idea of open data and making sure that everyone has access to it. So we have hypothesized or really posited to the community that achieving and implementing fair and open data sets benefits greatly from using modern, easy-to-use data tools and software, which again can open up access and make it a lot easier for downstream users who don't want to read the Wikipedia page on Buffer or spend a month trying to figure out how to compile a Fortran program to decode the data. So we made a commitment. We actually have a credo with NOAA that we announced last week on taking this Ninja archive applying some engineering magic and really rethinking how can we improve the adoption of some of the FAIR principles and how they're deployed to this data set. And we're republishing it again under a CC BY 4 license in a data set that we're calling Ninja AI. So the Ninja data set, but optimized for use in AI and ML modeling workflows, particularly those that will support this next generation of observation-driven forecasting, but as I'll show in a second, that actually support many different use cases. So for the sake of time, I'll skip over some details a little bit, but I just want to mention that we've put a lot of care and thought into how we're developing the archive and formatting the data. And I could give an hour-long talk on some of the decisions that went into that, but in a nutshell, we're trying to adhere to a set of engineering principles that allow the data set to interoperate with pretty much any data analytics stack that a user might use in the wild. So at the core of it, we're deploying this hierarchical high partition layout of Parquet files. So super standard technologies that have widespread adoption in both the open source and commercial communities. And what this means is that any developer could take their favorite tabular data set processing toolkit, if it's pandas or polars or equivalent things in R or Julia. They could point SQL processing engines at this data like DuckDB or enterprise solutions like Google Cloud BigQuery, or they could use scalable ways of working with large masses of data, everything from Spark to Apache Beam, or its enterprise implementations like Google Cloud Dataflow, things like that. This data set transparently works with all of those systems, propagates all the metadata that we've packed in it as well. So we really hope that this encourages people to work with the data. We've also built a Python-based SDK. This is a little bit tailored to some of the ML communities that we want to support in the initial run, but by presenting this SDK and hopefully it becomes multi-language in the future, what we're able to do is package even more metadata and tooling, which allows users to more trivially slice and dice the data set without having to know a lot of the technical details on the implementation of it. Again, just to go a little bit faster because I'm low on time. We have a large number of data sets that'll be published with this. I've given a snapshot of 6 different sensing modalities here and like 3 hours worth of data pulled from our reprocess archive. What's really cool is that, aside from the matplotlib code to make this pretty visualization, retrieving and processing this data from our archive was all of 6 to 10 lines of code. Whereas it would have been hundreds of lines of code if you had to process all the buffer files individually. So we really hope that not only can we enable people to explore AI and ML applications of this data, but we'll actually be able to find other use cases. So for instance, we're collaborating with NOAA and providing them a lot of information on where there are gaps in their processing of this data set, owing to the fact that I can trivially run a SQL query and identify the gaps much more easily than having to read through all the buffer data, since there's no externally facing metadata in any of those files. So we think that that's a big win for the community. We launched a preview release of this data really to get feedback on all of our engineering and design decisions. And we're going to feed that into a review process that we can continue making it more open. And actually, I'm quite interested in now applying the AI-ready data checklist and maybe publishing the outcome of all the decisions or all the factors on that to see where we land there. But it's published on Google Cloud Storage as well as on our SDK is on GitHub. And we have a DOI covering this as well, again, for provenance and tracing the availability of the data. And that'll get updated as we shoot towards our version 1.0 release a little bit later this quarter. So I'll take just maybe 30 more seconds because I'm at time. And I just want to mention that, we have some takeaways for the community here. I think the biggest ones are that we found the principles, like the FAIR principles and the AI-ready data checklist, quite flexible and easy to work with. It really let us focus on product-driven requirement discovery because we were confident that the principles were going to satisfy any of our end users. The downside is that we had to make a lot of compromises, and really we had to make compromises in the name of moving quickly, getting real-world feedback, and going through an iterative design cycle on the data. And that was very conscious. We want to have partners using the data. The best way to do that is ask them, how easy is it to use? Did we meet your needs, or did we make mistakes somewhere along the line? So we're actively doing that process starting probably next week, because I'm quite exhausted from the push to AMS to release this. And then the other thing that I'll mention is maybe a word of caution. This was a massive engineering project, especially for a 6-person startup, really with 2 people working full-time on this data set. And we do have concerns about the long-term maintenance and sustainability of this data. We're hoping that our creative with NOAA provides us mechanisms to support it, and are beginning to discuss to different groups, what that might look like. But we do think that's a really, really important call out to note that we don't want this data and this effort to go by the wayside, and we have to be quite deliberate about how we advertise it and build towards a sustainable plan for it. And I'll just leave, happy to take a question or two if there's time, and I'll leave just a little bit of a advertising slide for my company. We would love to hear your thoughts on what we're doing, as well as feedback on this project. And I'll stop there.
Thanks, Daniel. Very impressive. As always, Rob, I see you have your hands up. Please go ahead.
Okay, there we go. You have a minute. This is great. Thank you. Also, I love to see the new relationship with NOAA. At some point, Dan, would you be willing to quantify massive engineering lift? I think as we look across the landscape of all the other data sets that are foundational and can go through a similar journey, TBD on what team would do that. I think getting a feeling for what they're in for would be really, really, really helpful broadly to the whole community, to the degree that you would be willing to share.
Yeah, that's great feedback, and certainly I'll take an action item to kind of think of like what the right information we can share. I mean, loosely we put an engineering year into this data set so far, and that includes everything from developing some of the code to interface with the buffer. Honestly, that's been the most complicated lift. I didn't advertise it here, but we built a flexible algorithm for kind of automatically decoding buffer data, since there wasn't an equivalent tool in the community. The TLDR for you all, those who have never suffered reading buffer data, is you actually have to manually decode the data, kind of look up the structure in ASCII tables and kind of hard code it into Fortran programs to read the data. We came up with an algorithm to automate all of that, which we think is really valuable. And then there's the processing time as well. Buffer can be slow to process, and some of the files that we read are very, very large. And there are large engineering requirements from like the memory available on the system to read them. So I would say it's like 25% on the buffer reading, 30 to 40% on developing the infrastructure to process the data at scale. And then the rest is ancillary, like publishing the data, experimentation on the standards and things like that.
That's inspiring. Thank you. Appreciate that.
Thanks, Rob. Appreciate the question.
I think I see Rob was putting his program management hat on, trying to quantify the investment on that. And any other questions for Daniel? If not, I have one. I know you probably, Ken, go ahead. I think I couldn't hear you, Ken. Are you speaking right now?
Can you hear me?
Yes,
yes.
I can now.
Yeah, you go ahead because you were first. I'll wait for you.
It's more like kind of a staged question for Daniel, because I know in your AMS presentation you talked about catalogs and then how it's easier for people to find that with your new release and then the SDKs. So do you want to speak more about your cataloging? Because I think one of the issue we see in some of those data that's made available openly is that people don't know that's out there unless you know the direct link to the buckets or to the location. Otherwise, nobody can find it.
Yeah, that's a great question. And in my head, there's two components to the discoverability problem. One is like knowing that the archive exists in the first place. And that's a major barrier that I'll mention for the AI weather community, because a lot of the advancement from that community comes from computer scientists and machine learning experts and AI experts who aren't immersed in this world of weather and climate data. So there's a lot of, I would call it social engineering, that goes in and educating people on what data set is available there. The second part of it is the contents of the data. And we've adopted, shorthands and kind of schema names for like the contents of the data that reflect back on the original Ninja archive. And you can see a little bit of that in the two examples of the formatting of the data set and then the structure of the layout for the archive on the right there. What we hope to have and what we do have is there's lots of data in the metadata and the catalog we publish in the Python SDK. It's kind of like a fancy way of giving people the ability to do like fuzzy searching over the different data sets that are in there. And we want to support this with a website on the side that catalogs all the contents, provides both scientific explanations of the data sets as well as plain language of what it is, and can kind of help people. But we're very much open for feedback on what that should look like. because this is the first time that we've developed a data set like that. So we would be happy to have additional discussions with folks offline about how we can build the most robust catalog possible to support end users.
Thanks, Penn and Rich. And after that, we're going to move on to a more broad discussion with all the people in the session as well as other speakers with some questions. Penn, go ahead.
Okay, thanks, Dan. This is great. I have a question about how scalable this method is, because if we have extension to buffer, that's what we are working on to include some additional elements for climate.
Scalable in terms of like from the software and processing the buffer data, or in the sense of like executing a project like this?
If you need to add additional fields, how easy it is or difficult to do that?
So right now it'd be pretty easy if it's a buffer table or it's a buffer message that's included in NOAA's standard, like the latest iteration of like their DX buffer tables. You know, I'm gonna put an asterisk next to this because obviously we won't want to test it, but we should be able to decode it automatically with our software. And I skipped a step here, but when we actually process this data, we actually decode to an intermediate format that retains the structure of the buffer messages. It's kind of like nested tree-like structure that supports, you know, lists and things like that. And that's automatic. And we can actually, we disseminate that in Apache Avro typically, and then we reprocess it downstream into the format for this archive. There would be some novel work to define like what is the final format to incorporate it in this archive, but the vast majority of the engineering work would be automatic at that point. It would just be making sure that, you know, some test data matches the inputs and outputs.
Cool, thank you.
Thanks. Rich, go ahead.
Yeah, Daniel, that was awesome. This might be too meta, but I know that like some Pangea like folks have been involved with like Earth System Grid stuff and like trying to get them to think about chunking like in CMIP 7 and stuff. On the observational side here with buffer, you know, going to Parquet and all the work you've done here, is there some higher level organizations, like are people thinking about this at a higher level, like about sort of moving to something like this so you wouldn't be all just downstream like conversion or
Yeah, that is a great question, and it's definitely something we should follow up offline. The short answer that I would say, you know, and I'm going to put my Brightband hat on and represent the organization for a second. We really want to open this up to many, many more data sets. Ninja is just the first one that we want to have. We want to open access to as many level 1 products as we possibly can. We are collaborating with NOAA because obviously NOAA is world expert in this, and their archives are rather comprehensive, especially for the purposes of assimilating into NWPP models. But all of this data is downstream of things like GTS and WIS2 and the international infrastructure for coordinating and disseminating observations. We would like to go all the way to that infrastructure, but it's not clear if there's a political or engineering pathway to get there. So a lot of what we're thinking about is how can we build parallel infrastructure that might, you know, we can tap into the same streams and maybe make the primary egress of the data in these cloud native friendly formats. But this is going to be a multi-year project to figure all this out. So there's a lot to think about. And the last thing we want to have is yet another parallel data set of everything. So, but it's just not clear what we do to, you know, push back into NOAA and, you know, to be a tad political. A lot of the discussions we had prior to yesterday, we don't know where they currently stand in regards to how we can enhance our collaboration with NOAA to, you know, make more data available. So we will see and would love to, you know, pick your brain more offline about your thoughts there.
Yeah, okay, great, thank you.
All right, thanks everyone, appreciate it.
Thanks, Rich and Daniel. And I think that conversation is also a good discussion. And I would want everyone's attention to our session notes document. And thanks for those who are able to help with collective note taking. And in the notes that we have a few of those prepared questions, but I think some of them are related to the speaker's presentation early on as well. And so I'm gonna just put it in the chat here to see. We're gonna start with those 3 questions, but we're also opening up to any other general comments or questions that you may have after listening to some of the speakers presented today. One is that I think one of the comments or discussion we often hear, also a good example Daniel presented in the integration of different sorts of data, right? That the formats are different, and then how to work with those data, and what are some of the common challenges and opportunities to support data integration in the AI application development processes. And the other one is that the speakers also mentioned the diversity of environmental data from satellite to ground measurements, and then to the omics and then onto systems and model simulations was the common denominator in a way for us to focus on to support those AI application deployments. And the last one, that what are some of those use case or data type specific needs to support those developments, and are those needs mostly for data processing or preparation, or there's also things that mentioned in the checklist like documentation, quality, and access. And I think quality probably is a little bit more tricky, as some of the pilots, WDS pilot mentioned that quality can sometimes be context based, and there's no control vocabulary in some ways for the quality that leads to math question about how can we automate some of the assessments in those data sets. So here's just a few questions to start the conversation, and that can be answered by either the speakers or anyone who have thoughts on those questions. I'm going to be quiet. I'm going to wait until people raise your hands or start speaking. Also, if you're not willing to speak up, you can also just type in the chat or in the note document as well.
Well, I'll just, is it okay just to talk?
Hey, go ahead, Rich.
Okay. This isn't exactly, addressing these questions, but I guess one thing that seems super helpful is having these end-to-end use cases there where somebody, has solved some particular AI problem, and then, in weather or climate or whatever. And I know just like a couple of examples of these things, like Jupyter books that really lay out like the whole, end-to-end process. And I think those are super, informative towards understanding like both the data issues, of course, and then, all the data analysis issues that go in, and all the way through to the end. I don't know if there's any collection of those around, or, I know GeoSmart has a couple, but I don't know, if there's other groups, and if there's any sort of meta group that's sort of aware of all those different kinds of use cases that are being collected.
Thanks, Rich. I think a lot of those like notebooks or existing examples may be starting from a somewhat well curated data set and then moving to those development processes. I think what's the missing are from the raw data to those like more data AI ready, and then for that application downstream. So I think people usually start with that easy to use data sets in some of those use cases, which
So
is
the
natural.
ease of use. So I bet it's sort of related. I guess the ease of use sort of relates to the use case itself, right? Like different, like you were just sort of bringing up here.
Yeah. Thanks, Rich. I'm gonna ask if any of the speakers want to take any of the questions that's in the chat, or if anyone has other questions for our speakers. Yes, Daniel.
I thought I might riff a little bit on question one, with this need for applications to integrate data from lots of different sources and formats. And there's a common challenge here that I want to throw out to the community that might not be obvious, but well, it's obvious and not obvious at the same time. The person who, or the group that is going to do the integration is the one that's likely going to make all the decisions about how they disseminate the data. And it's not always the case that that group is designing for the larger community. So you see this a lot in the hyperscalers, especially internal engineering teams at like a Google or things like that, where maybe they adapt an internal technology or the public case open source version of an internal technology that they have for kind of integrating all the data. And it's great when that does matriculate and kind of be presented to the world. But there's not always that guarantee for long-term support, and data sets can get orphaned when that happens. The best case, I think, and what we should aim for are when these organizations kind of make the conscious decision to adopt like a growing open source standard. So for instance, Google Research publishing the ERA 5 reanalysis in ZAR, cloud optimized analysis ready format. And that has become the de facto, data set used for all of the AI weather modeling development to date. So that's a big success story when you can kind of marry the expertise of the integrating group with like a data and community that supports it. And it's a tale that I think we should strive to tell, so that other groups who are operating at the forefront can replicate it when the opportunity arises.
Thanks, Daniel. And just follow up on what you're saying. You're mentioning that you are republishing of the Ninja in a more AI ready data formats, and I think the cloud optimized formats of the ERA5 is also a republishing of the existing like ERA5. And I think going back to your earlier comments about the longevity and sustainability of this type of the model of a team working with domain expertise, trying to republish those like data from its native formats. And I think a question came up or will come up would be the provenance and then how to ensure those data are accurately curated and for the use, right? And the collaboration is helpful. And then what are other ways? How can we ensure the problems? And also going back to some comments about citation of those data and all that. Any thoughts for any speakers? Daniel, if you want to take it, you can take it.
Yeah, I'll just make the quick comment that like I think you said the key thing is that there are diverse communities that need to work together here. That means there's diverse standards, diverse goals, and things like that. And so I think having things like the AI-ready data checklist and other kind of like common standards that a group can say, here's a ready-baked set of solutions that will help with some of these problems is a way to go. Strongly support getting DOIs for data sets since it's mostly frictionless these days, especially when the software underlying the data set changes. And that's like one of the major issues I see with provenance in this field is that there can be subtle changes to the data sets that aren't really tracked. But if you're tracking the software that generates the data set, it might be one way to help deal with that problem. And maybe a shout out to some of the commercial organizations like Earthmover and others who are thinking of new technologies to address some of this as well. But these are big problems, and I think we should not pretend that they're anywhere near solved.
Thanks, Daniel. I saw Stephen come up on camera
briefly. Yes.
Yeah, go ahead.
I was just saying, yeah, I would absolutely agree with that. And I think one of the key things, talking about the kind of cloud-ready version of ERA 5, enables you, in order to make the most of this, you're going to have lots of different experts in different areas. Not someone who's like an expert in everything. So having those sorts of data sets that are like well-defined allow the people to work together with the different skill sets a lot more easily to tackle these. I think that's an important part of the kind of data readiness things. Enabling people, you don't have to be an expert in a particular data set to be able to use it, which is often a barrier in ML. So a lot of the developments for these big weather models have come from people who aren't experts in weather because the data set was well defined that be able to load and use in well defined tools, and that's. So that's as Daniel said, it's a really good template for like how we can accelerate things by making data sets available like that. What does that look like for observations? That's what Daniel's been looking at. There's lots of other areas as well where that's a good standard to be aiming at.
Thanks, Stephen. And I'm gonna pick up on one of the questions Rich posted in the chat, which is the discovery of the observational data set. And I think Daniel, do you want to answer any of the questions that Rich had, and have you thought about maybe using Stack and for some of those Ninja AI or?
Yeah, I mean, there's a larger problem here, and but not to like deflect the question a little bit, but sharing my personal experience, working in some of these interdisciplinary AI/domain research groups is that we're kind of still in the age of like encyclopedia human, where there's a very knowledgeable individual who is connected with the data producing communities and can kind of help curate the data relative to like the requirements that the the ML researcher is kind of thinking of. And just automated things for discovery and catalogs like stat catalogs are fantastic, but in my experience, they've been a mediator of like making it a little bit easier to get to the raw data, and like the actual dissemination of like what data set is available and should be used. Right now seems like a very human thing. Maybe there's interesting ways to use AI tools to kind of like share that knowledge through knowledge graphs and other interesting technologies, but in most of my personal experience, myself or another meteorologist or climate scientist who has been working with the data for a decade plus is the best way to discover what data set an ML researcher should be using.
Thanks, Daniel. Any others want to respond to the question that Rich had about the discoverability of those data sets? Stephen, go ahead.
Oh, I was just going to say, I mean, it's sort of on the same point, but I guess one thing that's changed over my involvement with data readiness is that I think is going to be really interesting to see how this interacts with some of these questions as sort of LLMs and a variety of emerging things. A lot of the things that needed to be really, really manual, to what extent can those assist with these like discoverability things, having these more. Well, are they more intelligent? I don't know. Possibly more intelligent tools to help with some of this. It'll be interesting to see how some of the like discovery and data readiness stuff can be accelerated by those tools. I think will be a really exciting thing over the next year or so.
Thanks, Stephen. I'm gonna point my last question to our data system representatives on the call, Andrea and Emily. So thinking from the data systems and repository point of view, where do you see it as there's a way to work with data systems or data repositories based on your pilot to help them to further improve or moving forward on this topic? Are you trying to do a rock, paper, scissors offline, trying to figure out who's answering it?
Sorry, I'm still just considering the question.
It's basically what you have heard from data repositories and how they're thinking about moving forward. I think Chandra gave an example of what she or they have been thinking about for Neon. Any other particular takeaways you can share from other repositories or the pilot project participants?
Almost everyone I've talked to has had an entirely different takeaway. So it's hard to like summarize it. Also, some of them are very specific. I guess just mostly people were interested in sharing the checklist around to people who had not heard of it before. Just trying to teach others in their community that this was a useful tool. That was probably one of the things that came up the most. I don't know if Emily had a different experience with.
Well, so far, as I mentioned, we're going through our one-on-ones with the repository representatives, and I've had two. One of them is still kind of starting out, so there wasn't too much to say there. He was also working on a very different kind of data and not earth science related, but I talked to Lucy Profeta from the Lamont Dirty Earth Observatory at Columbia, and something she said was that she didn't have too many troubles filling out the checklist, but kind of similar to what Andrea said, she wants to get out the word more on the checklist, and actually is hoping to do like an automation of it that can basically go into their depositor, like when the depositors do their list of of things before depositing. She wants that to go in there and as part of their like automated platform. And I heard Matt mention that earlier. So I think that would be really cool if people could collaborate on an automated version of the checklist.
Right. Thanks. I think that's one of the goal we want for this class, to collaborate with other groups who are already been doing the automation. So Matt, definitely we want to pick up the conversation with you again. And when we have some of the people who are willing to share the assessments and lessons learned from that. And great, thanks, Matt. Nobody want to, we don't want to recreate anything that's already out there by other groups. And on that note, we are right on top of the hour. Thank you everyone for staying engaged in this session throughout the 90 minutes. We have 45 or close to 50 people in the session today. And please keep an eye out for our regular monthly meetings. Pick up some of the conversations we had today. And thanks for Aaron and our community fellows, Nafalo and Ian on this call today. And thank you, everyone.